Bismillahirrahmanirrahim. Good morning. Today we will discuss important information related with the perovskite. We will introduce what that's mean, the perovskite, and after that I will focus by which of them, the perovskite or the normal solar cell, it's better. I will focus on the cost, which has the appropriate cost to us to can build a great system. What the different about the efficiency and why. We will focus on the general formula of perovskite structure. It's organic or inorganic. It's belong to N-type or P-type. What about the properties, the advantages of this topic, how the perovskite cell work, and many important titles like that. Let's start. Now let's know what that's mean, what the perovskite means. Let's give appropriate definition to this perovskite. It belongs to the ternary family of crystalline structure. It is defined as a network of corners sharing a BX sub6 octahedra. Octahedra, that's mean has 8 faces that crystallize with general ABX sub 3. Let's give some attention here. In another source, written ABO sub X. I will explain all of these elements, what that means. And here, this image illustrates to us the structure of the perovskite, almost belong to cubic structure. Here, we have 3 elements, A, B, X. A, B, all of these are cations. X is anion connected with all of these AB. Now, the perovskite is a simple cubic structure consisting of 3 atomic sites, A, B, and or X, depending on which source you follow. The oxygen forms on an octahedron around the B site. Here it's important. The oxygen O, or we can write X, forms an octahedron around the B site with the A site on the corners, and the corners just outside this octahedron. In the corners, but just outside the octahedron. Shows how the perovskite is simple cubic when looking at only the A and B site, or cations we can say. In an octahedral coordinations, each A cation is surrounded by 12 X anions. Like I said before, X is connected with all of these cations, A and B. Here is connected with 12 X anions. In a cubic octahedral coordinations, each B cations is surrounded but by 6 anions. The octahedral sites can host small cations, started from 1 until 6. Valence oxidation states. Here, each of X ion is surrounded by 2B. Now we will focus on X and what around the last shell of X. X at the last shell has, or at its shell has 2B cations and 4A cations. Here it's A, here B, here the oxygens anion. What are the major function of the perovskite? Perovskite here is very important. Here we will discuss what the difference between the normal solar cell and the perovskite, why the perovskite is better. Perovskite solar cells of certain composition can convert widely range of wavelength, different range of wavelength. That means not just the visible light, ultraviolet, visible light, and another wavelength. Because that means we can absorb more light, more different wavelength. What that means? That means we will have more usable, we can gain more usable electric power and visible light into electricity very efficiency. Here with the normal thin film perovskite solar cell, perovskite on silicon tandem solar cell, like that, meaning they might be excellent hybrid. The hybrid, that's mean not belong to this group, it's think from another place. We will try to put it in another group to can build different structure. Hybrid tandem partners of absorber materials such as crystalline silicon that efficiency can convert inferior wavelength, inferior light. That's mean here we dealing with perovskite can convert all of the ultraviolet, infrared, and visible light to the usable electric power. What is the general formula of the perovskite structure? A sub n minus 1, B sub 3, sub n x, between two brackets, 3x, 3n plus 1. I repeat that again, A n minus 1, B sub n, between two brackets, x, between two brackets, 3n plus 1. And the structure formula for the layered perovskite, and let's know what that's mean, and indicates the size of the two-dimensional slabs. Here, for example, when we say n equal, well, what that's mean? That's mean indicates one layer of dx sub x, octahedron thick, and when n equal 2 means that the structure is 2. Bs sub 6 octahedron is thicker than. Under some deposition conditions, the material belong to be p-type. Perovskite structure tends to be p-type. Now, let's focus on this note. The perovskite is organic and at the same time inorganic. Perovskite material belong to all of them. As the light harvesting active light, a layer, it's processed at low temperature rather via the printing techniques. Here it's important. We will discuss the properties or the characteristics of the perovskite. Here, they exhibit attractive physical and chemical characteristics such as electronic conductivity, electrically active structure, variations on the content of the oxygen, thermal stability, chemical stability, supermagnetic, photocatalytic, thermoelectric, and dielectric, and more. All of these are the characteristics of the perovskite. Now let's discuss the advantage of the perovskite. Let's start from it can react to various different wavelengths, like I said before, ultraviolet, infrared, and visible light, which lets them convert more sunlight of the sunlight, absorb more wavelength that reach them into electricity. That's number one. Number two, offer more flexibility, semi-transparency, fitted form factors, lightweight is important, and it's inexpensive because it's abundant, and more. How do perovskites works? Let's discuss this topic. Any different with the solar cell, or maybe it use different system? Solar cells made with perovskites work in a similar fashion to traditional solar panels. That means it's a huge similarity between them. A semiconductor absorbs solar energy and initiates a flow of electrons, which is captured by wiring and converted into usable electricity. Why the perovskite is a semiconductor? Because his behavior. Let's focus on this slide. Perovskite are semiconductor with an organometallic, or we can say oxide structure, that can absorb and emit light. Because his behavior here can absorb and emit the light like the semiconductor. It is useful to optoelectronic applications like what? Like LED and solar cells. But simple method here, we have a note. It's difficult to manufacture the perovskite at three-dimensional shapes. How much do perovskite solar cell cost? It's very important because we know when we decide to do any project, the cost and the benefit will be at the first on the list, because that is very important. If this thing is great but has expensive cost, we can't pay to build this project, something like that. That means this project will fail. Because that the cost is very important, we will discuss the cost after advantage of any topic, of any project. Here, his cost is cheaper than the solar cell because at the perovskite, we will pay to do any per square foot just $0.25 to any per square foot. But this situation is different with the solar cell because we must pay to any per square foot $4 to $10 to any per square foot. That means we have a huge difference between all of them in the cost topic. What are the perovskite materials? It's a structure as a mineral calcium titanium structure, or the mineral calcium titanium oxide. Generally, perovskite compounds have a chemical formula, like I said before, ABX sub 3 or ABO sub 3. A, B represent cations, X is anion that bonds to both. What is the coordination number of the perovskite? As the coordination number of A equal 12, but at B equal 6. That means coordination and A bigger than B. The larger cations is mostly a transition meta, and that will give some freedom to make B move more comfortably. The perovskite structure in an ideal perovskite structure is the last slide. Like I said, in my opinion, the most important slides were the cost, the properties, and the perovskite advantages. Here for the cubic strontium titanate, SrTiO3, at first at previous slides, what I said A, B, O sub X. That means A, cation A equal SR, B, cation equal Ti, and O3 equal O3 or X3 like you want, depend on what you want. A cation, SR, is coordinated to 11 oxygen ions, anions. B, its Ti cations are coordinated to 6 oxygen anions. Here, this image illustrates to us perovskite structure by taking SRTIOX, a good example to illustrate the perovskite structure. Here, the A cation bigger than B cation, like I said before, and oxygen wall surrounded by 2 A cations, 4 B cations. This is the old information taken from the previous slides. Now we have another thing. We will discuss what is the T element. Here at first, let me say there is a contact between A, B, and O ions. Here, between two brackets, R sub A plus R sub O equal R sub B plus R sub O dot root 2. When Ra, Rb, and Ro corresponds to the crystal radii for cations A, B, and the anion O. The stability of perovskite type phase for particular group of cations and anions is related to tolerance. Tolerance is an important factor, is an important element. Let me repeat that the stability of perovskite type phase of particular group of cations and anions is related to tolerance, or we can say T. That means the stability of the perovskite will depend on tolerance. What is the tolerance? It's a variable factor with reached to the limits for the cation size. Related with the cation size is the variable factor with regard to the limits for the cation size. Its dielectric properties. Here is important how we can calculate the tolerance T factor. This parameter T defines the symmetry of the system and the effects. Illustrates, defines the symmetry of the system and the effects. T equal what? T equal between two brackets R sub A plus RO divided on root 2 RB dot plus RO. When T value is close to 1, will be always close to 1. Less more, less than. The perovskite phase is formed, although some perovskite structure can form in the range from 0.9 until 1.1, no more than. When the tolerance factor T is bigger 1, that's been reached to 1.1, not bigger than 1 by a huge difference, with a huge difference. Big A cations bigger than B cations. That's dependent on T is bigger than A or not. Bigger than 1, bigger than 1, that's mean A bigger than B. Less than 1, that's mean A smaller than B cations. The B cations here, when A bigger than B, when T bigger than 1, have a larger space to move. When T is smaller than 1, A cation smaller than B, and the cations have small space to move. Non-perovskite can crystallize on all possible symmetries from cubic at high symmetries to triclinic with low symmetry. From cubic with high symmetry with triclinic with low symmetry, with cubic and with triclinic. Here, crystal structure at ideal perovskite as cubic structure, and the ideal from the crystal structure of cubic perovskite can be described as consisting of corners sharing Bx6, the same for chemical form, octahedral with the A cations occupying, sorry, the right pronunciation to this word, occupying the 12-fold coordination site formed in the middle of the cup of 8 such octahedron. It corresponds to T equal 1. When T differs from 1, it gives plus to perovskite with low symmetry, like strontium titaniate, SrTiO3, strontium titaniate. This figure illustrates to us the strontium titaniate, SrTiO3. This few only is important note, because that's related with the review topic, because that I put it in the summary slide. Only a few perovskite type compounds exist in nature. Their original scientist names and the discovery sites are listed below. If you're interested to this topic, you can take a look to this column. The important thing to us, only a few perovskite type compounds exist in the nature. Here it's a summary to the important points related in my presentation. You can take a look if you're interested. Thank you about your watching or listening. I wish this video was helpful to all of you. Have a good day. Thank you. See you in the next lecture.